A coin is flipped 4 times and its results are recorded. Consider the two events, H, the first 2 flips are both heads, and E, there is an equal number of heads and tails. Are these 2 events independent? Alright, so we know that 2 events are independent if knowing that one has occurred does not change the probability of the other one occurring. So, for example, if E and H were independent, then knowing that the first 2 flips were heads, my probability for having an equal number of heads or tails would remain unchanged. Okay, so what we can do now is we can calculate these 2 probabilities, and if they're equal, then yeah, they're independent. If they're not equal, then knowing about H would make E more or less likely, and so they wouldn't be independent. Knowing about one would tell you about the other. Okay. So these are what we're going to try and calculate. Now with the coin flip scenario, okay, it's a nice fair coin, we're going to have an equiprobable sample space. Okay. So there's lots of ways we could approach this, but with 4 flips, we could even just write out every possible set of flips. Right? You can have 4 heads. You can have heads, tails. Okay? If we think about it, there's going to be only 16 possible coin flips here. Okay? Now, this isn't the only way to go about doing the question, listing out all the possible outcomes in our sample space, but it's certainly an interesting approach that works for small cases. Okay, so the remaining 8 of them will be, start with T's. So I'm just listing out the first 2 here. It's heads, heads, tails, tails, heads, tails, tails. So there's all 16 possibilities, 2 outcomes per flip, 4 coin flips. Okay? So each of these has a probability of 1/16. Okay? Now let's see if we can identify our probabilities. So equal number of heads and tails, where are those? Well, there's that one. That one, we need 2 heads and 2 tails. So there's another one. Okay, 2 heads, 2 tails. There we go. So 6 out of 16 possible outcomes resulted in an equal number of heads and tails. Okay. Now what we're going to do is we're going to identify the ones in event H. Okay, so these are the ones that have the first 2 coin flips are both heads. So conveniently, that's just the first column here. Okay. So now, if we restrict to this sample space, we might see only 1 out of these 4 is in our event E. Okay, so the probability of E given H is 1 out of 4, whereas if we simplify the 6 out of 16, we get 3 out of 8, whereas this is 2 out of 8. So these are different probabilities, so they are not independent. Now you say, well, that's all well and good, restricting sample spaces, talking about these sorts of things, but what if it was a different question where there were 40 coin flips? Okay, how can I do this without listing out all the sample points? And that's a good thing to ask. Yeah, we can answer this question, but what have we learned that we can apply to other questions? So let's try it a different way. We're still dealing with an equiprobable sample space. So if I want to know the probability of E, okay, we count the number of ways to flip with heads and tails equal out of the number of ways just to flip our coins. Okay. So, if we've got an equal number of heads or tails, imagine your 4 coin flips. We need to choose exactly 2 of them to be heads. So there's 4 choose 2 ways to flip an equal number of heads or tails. And as already remarked, each flip has 2 possible outcomes. We're flipping 4 times. So 2 to the power 4. So this is another way to get the 6 over 16 here. Okay, without listing out all the sample points. Okay, and it's good to be able to realize that there are other ways to do things. Okay, so that gets us our 3/8 again. Now what about the conditional probability? What would we do there? Okay, instead of listing things out and isolating what h is, what could we do? Well, it's an equiprobable sample space. So as always, we can trade a probability we want for 2 counting problems. So we're going to figure out the number of ways to have 2 heads at the start and an equal number of heads and tails, and then divide by the number of ways to have 2 heads at the start. Okay. Well, if I have 2 heads at the start, so if h is satisfied, in order for e to be satisfied, to have an equal number, you have to have the last 2 be tails. So there's only one way. Okay? There's only one sample point in h intersect e. Now, if we know the first 2 are heads, how many possible coin flips of 4 coins can result in 2 heads at the start? Well, there's 2 choices for the 3rd and 4th flips, but the first 2 are determined. So there are 4 ways to flip with 2 h's, 2 heads first. And so this is an alternate way, but you'll notice it's the same probabilities we saw before. Okay, we're working them out more as counting problems rather than listing out all sample points. 2 equally good techniques, though. Okay. But we notice this is not the same as 3/8. Okay. So if these are not the same probability, then once again we conclude, same conclusion. Okay, we just did the question differently. We didn't do a different question. They are not independent. You could have also, and I'm not going to do this, assumed that E was given. Okay. And asked, all right, is the probability of H equal to the probability of H given that E has occurred? Now, since E and H aren't independent, we know these won't be equal, but I will leave it to you to try and work these out. Either by listing out sample points, which is fantastic, or doing the counting work that we did. You can try it either way, and I sincerely encourage you to do so for practice.